So this time we're going to find the equation of a line, but we've got some information. It says the equation of the line that is parallel to y equals 4x take 3 and passes through 5, 14. So I guess sometimes I like to start with a little picture just to make sense of it. If here's my Cartesian plane and the equation for x take 3 went through here, okay, we're looking for another line, a different line that's parallel to that. It could be here, it could be here, it could be here, but it's all travelling in the same direction. And I just don't know where it is. I do know one thing about the line though. I know that it passes through a point, 5, 14. So somewhere there's a point, could be here, could be here, could be here, which is 5, 14. Okay, so I've got to work out which, where it is, or what the equation of that line is that goes through that point and has that parallel gradient. So whenever we find lines, we're looking for y equals mx plus c. We start by finding the gradient. Now, we don't have 2 points, so we can't use rise over run or the change in y's over the change in x's. But we do know something. We know that my imaginary red line or mystery red line is parallel to this. Now, this equation has a gradient of 4. Any other line that's parallel to it must also have a gradient of 4. So I know that my gradient is 4, which means I can write my equation using that information. What I don't know is the y-intercept. So I'm going to use what I did last time. I'm going to choose a point. I'm going to remind myself which one's x and y, and I'm going to substitute. So y is 14 equals 4 times x, which is 5, plus some number. 14 equals 20 plus c. Well, 20, what do I need to do to 20 to get to 14? I need to take away 6. So this must be take 6. So c is equal to negative 6, or I could have rearranged it. Therefore, my whole equation is y equals, back up here, 4x, take 6.